Hello again and welcome grade 12s. This is the last example for our equilibrium lesson. I will continue by solving this here. Okay, so this example starts off. It says a student combusts a sample of propanol in a bomb calorimeter. This is not a calorimetry question. We are done with those for now. The student begins with a certain amount, get out a highlighter, a certain amount 0.6 moles of propanol, 2.3 moles of oxygen. The final concentration, this is an important value, the final concentration of propanol is found to be 0.15 moles. Okay, this implies that this value exists at equilibrium. Determine the equilibrium amounts of all reactants and products. Okay, so let's start. As always, begin with a balanced equation. So take a moment, balance your equation. Propanol is from, well, you should be able to figure that out. It's from your organic chemistry unit, our first unit. Okay, so it looks like this. Now our ice table. Okay, these are mole values, different from the previous question. The previous question looked at concentration, molar concentrations. These are now mole values. So I'm just filling in all the information the question gives us, which is almost filled in. Let's go over it. So initially we have 0.6 moles of propanol, 2.3 moles of oxygen. At time 0, before these react, we don't have any moles of our products made, so we write 0. Now these values, these mole values will change. Our reactants will decrease, so we write negative. Our reactants will decrease by a certain x value, right, related to the coefficients in the balanced equation, so it'll decrease by minus 2x. Oxygen will decrease by minus 9x because it is being consumed. We write negative here. Our products will increase, right, because they're going to increase in amount, in mole amounts. In this case by 6x. We don't know what this x value is, but we do know that it is going to, or that it is related, and it is proportional to the coefficient in the balanced equation. And now for water, we're going to get an increase in moles of water, not concentration. That's for later discussion. Here we get an increase in 8 times x. Okay, now we take I and C, we add them together for expressions of all of these species at equilibrium. We get 0.6 minus 2x. We get 2.3 minus 9x. 0 plus 6x is just 6x, and 0 plus 8x is just 8x. Good, so now we have concentration, rather, not concentration, we have expressions for all these species at equilibrium. Now, this important piece of information here will help us solve the rest. Okay, so at equilibrium, okay, we have a certain number of moles given to us in the question, right? 0.15. Okay, moles of propanol. We also have an expression for the number of moles of propanol at equilibrium. So we can equate those two. We get 0.6 minus 2x. Right? Do a bit of math here. Divide both sides by 2. Going to get x is equal to 0.225. Okay, again, let's remember what our units are. We get 0.225 moles of x. Now, we have to solve then for our equilibrium amounts of all reactants and products. Okay, x doesn't represent anything really, but it is, we now are able to plug them into where we find x to find out all those amounts at equilibrium. So let's do concentration. Oh, we're going to write concentration again. It's not concentration, it's moles. So our mole value at equilibrium of oxygen, right, I'll put another subscript here, at equilibrium is 2.3 minus 9x, right? That's the expression at equilibrium. But now that we know what x is, all you do is substitute. So back to grade 9, substitute our value for x, and we'll get 0.275 moles of O2 at equilibrium. Okay, a couple more to do. Our expression for CO2 is 6x. Last one, number of moles. Getting ahead of myself here. Okay, number of moles of water at equilibrium is 8x. That's our expression. Plug in our now known value for x. It gets 1.8. At equilibrium. And that's it. Let's see. Sig figs looks like there is just one, right? So we'd have to round this all to one sig fig. This would be 0.3. This would be just 1, and that would be 2. Right. Okay. Hope this helped. I hope you're taking note of any questions you have, anything that is still not entirely making sense. Pause, rewind, watch this video again. I'm going to certainly post more, and don't forget to ask questions on Teams.